Let's see. How long do you think you need to fully solve this problem? Like you have the final answer. Here's the min, here's the max. What do you think? 5 minutes? Okay, we'll do 5 minutes. No calculator. How about that? No calculator. You need until the end of the semester? I hope not. Did we all finish it? No? Yes? Maybe? Well, who's going to tell me how to start this problem?
I used product rule to find the derivative.
Okay, so we found the derivative. Okay, good. So the derivative is e to the negative 2x times 2x cubed times 2 minus x. Cool. We have the derivative. All done. We use the product rule, we use the chain rule, and then we factor stuff out. All right, next. So you found the derivative. That was your first step. What do you do with it?
Find where it doesn't exist and where it equals 0.
Okay, good. In other words, find the critical numbers, right? Okay, so like Dina said, she reminded us there are two types of critical numbers, right? Where does the derivative not exist? Where does the derivative equal 0? Where does the derivative not exist? Didn't all of you just work on this for like 5.5 minutes? None? Right? Right, none. Right, the derivative exists everywhere. Where is the derivative equal to 0? 0 and 2. Good. X equals 0, x equals 2. Right? Because remember, once you find the derivative and you factor it, right, setting this equal to 0, let's remind ourselves, when we set this equal to 0, when something is already factored, what is the nice thing about e to the negative 2x? Can someone remind us about a property of e to the negative 2x that helps us solve the equation f prime equals 0? Like Jan said, it never equals 0, right? E to anything never equals 0. So when you have this whole thing equals 0, you can actually cancel out e to the negative 2x on both sides. And you're just left with the last two factors. But those two factors are easy to solve, right? You get x equals 0 and x equals 2. So even though you have an e to the x or e to the negative 2x in here, it's really not that scary, right? Because it just cancels out of the equation. Okay. All right, so now what do we do? So I have my critical numbers, and now what? What's the next step of my problem?
You have to find the candidates.
Right, I have to make my table of values.
So we have, should I tell you?
Yeah, go ahead.
0, 2, negative 1, and 10.
Okay, good. So my x values are 0 and 2, right? Because those are my criticals. And then it was a negative 1? Yeah. Negative 1 and 10. Okay, we're dealing with a satellite calculator. My y value is x to the 4th, e to the negative 2x. Okay, well, the 0 gives us 0. Duh. What does the 2 give us? The 2 gives us 16 times e to the negative 4. So I'm going to write that as 16 over e to the 4. That's probably a better way of comparing it to the other numbers. And there, what about negative 1? So the negative 1 gives us just e squared. Right? Because I get 1 times e to the negative 2 times negative 1. So I just get e squared. Okay? And what about the 10? So 10 to the 4 is 10,000. And then I get times e to the negative 20, which I will write as, we'll say that this is 10,000 over e to the 20. It's a little bit easier to compare that to everything. Okay, so good. So we have 4 numbers, right? I need to figure out, well, which one is the largest, which one is the smallest, without using a calculator. This is it's really not bad to do without a calculator, right? Don't get scared because you see e's and you're like, I don't know what to do. So first of all, can someone tell me what the absolute minimum is? So the absolute minimum is completely trivial. It's completely trivial to figure out which one of these 4 numbers is the least. 0, right? The other 3 numbers are all positive, so clearly 0 is the smallest of these numbers. Now, what about the absolute maximum?
It's the last one.
So you're going to tell me it's this one. Do you agree with Pranav? Does anyone have a different opinion? You thought it was e squared? Did anyone think it was 16 e to the fourth over e to the fourth? How can you actually figure this out? Well,
Well, E is like 2.7 something. So we know 2 to the fourth is 16. So 16 divided by 2.7 to the power 4, that would be less than, I mean, it'd be positive, but less than 1. So
okay, good. Actually, that's a good way to think about this, right? So Jitesh said that e is between 2 and 3. And we know that, so this is essentially 16 is 2 to the fourth. So this is 2 over e to the fourth power. But 2 over e is clearly less than 1, right? So Jitesh was saying, okay, this is a positive number, but it's definitely less than 1. What about e squared? Is that bigger than or less than 1?
it's greater than.
Right, it's obviously greater than 1. So far I can eliminate 16 over e to the fourth because e squared is bigger. And so really it comes down to, okay, is e squared or is 10,000 over e to the 20th bigger? Now, 10,000 over e to the 20th is a very, very, very tiny number, right? It's like Jitesh said, right? Even if you want to super approximate this, this is like 10,000 over 2 to the 20th. That actually makes the number a little bit bigger, right? By making the denominator smaller, right? Going from e to 2 makes it smaller. I've made the denominator smaller, and still this fraction is super, super tiny. I mean, 2 to the 20th power, and that's a very, very large number. So this is a very, very small number. Very tiny. So it should be clear then that e squared is actually the biggest of these numbers. All right, questions about this problem? Questions, comments, concerns? And you will have a calculator on the exam, obviously. You can always use a calculator. But, you know, you should be able to do these things without a calculator.